So we created some new updates to the front end and our open source vision system. So this is the project that I'm doing with my company NN Code, where we help companies like building AI, computer vision solutions, and so on. But we have built out this computer vision system that both have a front end, back end, database, all the AI integrations, and open sourcing it. So you can go through it for learning purposes, use it for your own applications and projects. But this is very much just processing videos, real time, generating detections in a database, and then you can see them in your dashboard and video analytics. So go in here, start it, go in, make contributions. If you have any suggestions, make sure to drop them. But we have created this new UI, which is a bit more refined, and all the pages are working. I'm pretty much just going to document the whole journey when we're building out the system. The base system is already there, but we're just going to create more features and functionality into the system. So in this video here, we're also going to take a look at some of the backend functionality, how the backend runs, the tech stack we're using. I have another video where we had an introduction going through the full system and all of that. So make sure to check that video out. You can go in, start it, clone it, do whatever you want with the system. It's open source. Right now it supports the Ultralytics models, but in the future, we're going to support any update taking model available out there, and especially the open source ones. So this is the code base. We have our backend, front end. It has Prometheus, Grafana functionality as well, and we keep refining that and building it out over time. This is the README file. Everything that you have to do, you need to have an environment file. Go through the setup, initial setup, create a Python version environment if you're using Anaconda or whatever. We start our database with Docker Compose. It's just going to create a local Postgres database where all the detections that you're getting is going into. Then you can apply the business logic or your project logic on top of those detections. So first of all here, let's go in and set up our initial setup. I'm going to copy paste this command. We're inside here. Now we have an environment file where we just have our example. So this is going to set up our database integration. Let me just throw this over to the left. And then we have our database integration. All the settings you need, the database URL, we have the Grafana, we have our API, where our port is running for our fast API server or backend. We also have our vid API URL, so this is where the front end will be running. Now we need to go in, activate our Python environment. There we go. I already have it running from another video. We can activate it. I'm just going to create it from scratch. We pip install the requirements file. This is everything that we have to do. It will do all the setup for us. We can then, while it's doing that, go in, create a new terminal. We just Docker Compose up. So what we're doing inside our Docker Compose file is basically just setting up our Postgres database. It says a Prometheus and Grafana as well, but right now we're mainly using our Postgres database. So if we go back to the README file, once we have our database up and running, there we go. We can now see it's running. And if we go inside our Docker desktop, our vision system is running down here for our containers. So next thing, let's go in, CD into our backend. We can also just, there we go. We don't even have to CD into it. It's just gonna grab it from here. So the backend folder, the main file, and it's going to activate the app or start the app. We activate our virtual environment. We use UVcorn and we have -- reload. So if you make any changes to the system, so this address here is already in use. If you get this error, maybe you have some other projects and so on running. I usually just go over here, kill this port, and have AI just help me out killing a port. Maybe you have other systems running in your Docker setup or in the background. Maybe you're closing terminals, opening up terminals, and so on. Sometimes the ports are blocked. You can go in and change the port number as well. So if inside the environment variables, we can just change the Postgres ports or the ports where we run our backend or our front end as well. But this is just so everything works together. So I can see I have something running on Docker on this port. So let's just gonna kill this. We need the PID 80259. So let's now go inside our README file again and run our backend. Now our database is running. There we go. We run our backend. It's now running on our local host and port 8000. Next thing here that we need to do is just start our front end. We open a new terminal. So we have one terminal for our Docker Compose file with Prometheus, Grafana, and our database. And then we have our backend system running and our front end. So now we cd into our front end. Make sure to activate our environment. We don't really need this for front end. We need to npm install. So this is all the dependencies for our front end. We're using npm install. So I need to have sudo in front. We're using React, Vite for the server, just running locally and all that. And then we have Fast API in the backend, Postgres, Analytics for all the update text and so on, but we can use whatever. So now we have installed all our front-end dependencies. So we npm run dev, and it should serve our front end here. So if I open it up now, we will get our computer vision system. It's running with the backend, the front end, and everything. And this is the new UI that we are looking at. So all these things here, if you have any active cameras, total detections in your database already, I just started the system, so I don't have any detections yet, but you can see the values in here. You can go directly to the object detection. It redirects to it, the active cameras for the live analysis. If you want to set up a camera, you can go to the settings. So it runs both object detection, segmentation, post-estimation, but I went over that in the introduction video, but also how to set it. So now we can go in and add a new camera inside the settings. Let's just call it live. We can have a live stream, recorded video, pre-recorded video, where we just upload it, or an RTPS stream. So now, just a 0th index, you can have your stream URL, your RTPS stream URL. Right now I'm just 0 for my webcam. We add the camera, and now we can see it here. You can add an arbitrary number of cameras. It will go directly into your database. If you're facing any errors with the connection to the database, make sure to go in and just check off the correct password for your environmental variables. So these are just placeholders for now, but if you want to create your own special password that no one can access or know of, you can create it in here in the environment variables. It will use that once you start up the database and connect to that one. So if you go back here again, we now have our live webcam. You can add how many you want. If you go to our live analysis, you can also go to home. So now we can see we have 0 active cameras. We have our dashboards. We have 0 out of 1 camera. I have some detections running in the background or from previous tests. So for the live analysis, we can start the stream. Should open up my webcam here on the front. So now it open up my webcam on my phone. So right now it's running here. We can turn it around. We're getting our live detections directly in the system. See, we get some cops. Nope. T-shirt. Nope. We get a potted plant here on the desk. And if we turn around, we get a purse detection. So then you can apply your own logic, what it needs to trigger based on the detections. You can have multiple cameras running in here, and they will then go into the detection. So 10th of August, we get some detections from our live camera. We're detecting a bottle, and we're also detecting a person. You can filter it based on your cameras. So these are the 2 detections that we just got. You can search for it and whatever. There's also white mode, so both light mode and dark mode, depending on what you prefer. And all the metric, everything, detection rate, object detection, you can see some graphs, dashboards in here as well. So now let's jump into our code and go through some of the backend systems. We will create another video where we go through the front end. And again, we're just going to keep making it public here. It's open source code, you can contribute to it as well. You can come up with ideas. I'm going to track the progress, create the progress here on my YouTube channel, LinkedIn, and so on. So definitely make sure to follow along. If we go inside our schemas and our models, this is pretty much just how we're setting up the cameras and the detection events, what goes into the database. So it's pretty good to just start here at the schemas and the models. So for example here, when we want to create a camera, we have a Fast API endpoint where we put in the stuff in the front end. It's going to call that endpoint with the settings. We get our response back if we have created the camera successfully or whatever. And then that endpoint is going to put it into the database. Then once we go into the metrics, we go into the dashboards and all that, it's basically just looking in our database, creating a new endpoint for our analytics endpoints and so on. We call with the filters from the front end, our request to the backend, where our backend connects to the database, pulls that information, does some analysis depending on what we want, returns the results again to our front end for visualizing it. So when we create a camera, we use Pydantic base model. We need to specify a source name, a stream type, live stream, RTPS. So these are the exact fields that you saw inside the front end when I just created a camera. The stream URL, 0 for webcam, and then also the location of our camera. We can have a config here as well inside our camera model if you want to have. Could be any type of attributes or metadata and so on connected to your camera as well. Inside our models, we have our camera definition, we have our detection events. So these are the base models that we throw into our database, but also return to our front end. So when we have a detection, we have a unique ID, so we can always pull up our detections later on as well. Let me minimize this so it's a bit easier to see. We have our model type, so what model are we actually processing our detection event on. And an event can be anything. It can just be a detection of a person. It could be some logic that you put into it with your business logic before it triggers an event. Maybe it's not relevant to see if we detect a person. Could be if a person is present in the frame for 2 minutes, then we want to raise a detection event. We have our timestamp, class name, camera ID, and our camera name as well. So we have all information here needed to go in and create a detection event. Then you can show a preview of the detection we get. You can pull up the camera ID, you can filter based on it, and everything that we need. For the camera base model here as well, we have our table with our cameras. A table in our database is our detection underscore events. Have our ID, source name, stream type, exactly as I just showed you inside the schemas. So when we create a new camera, we initialize it with these parameters, create it at, and then the 4 types that we type in to the front end. So our front end, all it's doing when we hit settings, create camera, it's going to grab the input that we give it in front end, create a base model, and then it will use that to put it into the database. Then we can always retrieve it again, but this is what our create camera endpoint is doing. So if we go inside our main.py, we have around 1,000 lines of code here for our full backend system, and we're going to add over time, restructure and so on a bit, but this is very good for just learning purposes. At the top, we set up our fast API server. So this is just our backend service running. So we have our app, then we can connect multiple different endpoints to this app. We can have a middleware as well. It could be that we have multiple different services that we want to run on the same port. It could be that we have multiple different services running on separate ports as well that we need to connect and have our front end working on top of. But this is still a very basic computer vision system. But we have all the components together, the front end, back end, database, everything that you need to have something basic up and running and actually get it out there. So we have some global variables for last capture frames, video captures. We're going to use threading as well, so we can keep track of which streams are getting started, which streams are stopped, and basically just isolate them so we can delete a camera as well. It's going to clean up all the resources and everything. So this is just good coding practices. One thing to mention is that this both supports CPU, GPU out of the box because we're just processing it with YOLO. So the first endpoint that we have is just fetch cameras. So we have our local host here. We're going to add just a base URL, but just understanding that this is a local system. You could also just have a function that generates a base URL. We have our API service here. We can use the visit configuration locally just as a proxy to reroute our endpoints. So then we just have APIs/cameras, and this is what we're going to call when we call this fetch camera function. So request, we just send a request, get to this endpoint that returns all the available cameras that we have in our database with all the metadata, if the camera is active and all that stuff. We get the response back, we just return our JSON, and then we have all the cameras. Then we also have a function for processing the frame. This is just a backend function for once our camera is live, it just does the detection this automatically. So we just have a frame. We get our frame to our process frame. We get our results variable. We have our camera ID. And again, make sure we both support object detection, instant segmentation, and post estimation. We have some color constants here defined just for showing the visualizations. If you want to use it for your own applications and projects, apply your own business logic, your own project, this is the function. This is pretty much just the only function you have to modify, create multiple functions that gets called in here. This is all the functionality going into the events, the computer vision detections, and everything. So you can see here, it's around maybe 200-300 lines of code. a lot of logging, a lot of visualizations and all that, so maybe 100 lines in total. You can swap that out and it will automatically apply inside the computer vision system. Still have the database, still have a full functional front end. You just need to have the correct database structure. You can also modify the database structure, but if you just change the process frame function, make sure to have this correct database structure as well, and everything is working. So let's go through some of the things that we're doing here. So this is for key point detection. So if we want to handle post estimation, we're going to get the points in our skeleton. We just loop through all of them. So this is actually like once we get our detections for YOLO model. Now we're just going to draw our skeleton. You can do calculations based on the key points that we're detecting. Right now we just visualize it, throw it into our database, but you can do whatever you want with it, with our key points, with our segmentation mask that we get out, and also here at the end, just object detection. So here, for example, we have a for loop just running through all our object detection bounding boxes. We extract the XY, so the top left corner, the bottom right corner. We have a confidence score, the class name, and then you can apply your own business logic here instead of drawing the rectangles and just drawing the label text as well. This is all that goes into this function. Here we also just have some modified tracking logic, so you can track it over time. So how long has these objects been detected for? Then we can go in and save an event to a database. So here we're just handling detections. Down here we're handling the actual business logic that triggers an event. So we run through all of it here. We get our valid detection. So right now we only got the person and the bottle inside our database. So that's why we only triggered those, or inside the front end. We check if it's a valid detection. If the class names are not in here, we're basically just going to save the event to our database. We check if it's model type, what model type it is. We need to throw that in when we create an event. Save event to database, the class name, model type, and camera ID. That's everything that we have to do. If we just skip to this save event to DB, it takes the class name, model type, camera ID. It's gonna grab and query that camera from our database to get the camera, and then we create an instance of our detection event with our class name, model type, camera ID, and camera name, and also timestamp for our current time. Then we can call db.addEvent. It's going to commit it to our database, and this is just how we save a single event to our database. So once we call this function inside our process image function, it's going to save it to the database. Once it's saved to the database, it automatically gets fetched into the front end. Let's scroll a bit further back here. So this is the main functionality that we have running. We can capture frames from a camera. So we have multiple threads basically just loading in from different camera sources. So you can have a live webcam, you can have a video file and all that. It loads in the frames into buffers, or basically just into a queue. We handle it in with threads as well. So each camera is handled with an individual thread. So you have much better camera control. So here we have the thread info with the camera ID, camera name. That's all we pretty much need. Then we can always pull whatever we want to do with our camera. So what we're doing here, we have a camera ID. We sort our database table based on the camera. We return our camera and our camera name. Then we can go in and start a new thread with that specific camera, and we will go inside our while loop, just loading in frames from our web camera and processing the results. So this thread will be started for each individual camera, capture frames from camera. It will go down here in the while loop, just running as long as this camera is set to true. So this is how we handle which cameras are active or not. Then we take our model, throw our camera or our image through a model, we get the results back. So this is just the Ultralytics object detection model. If you want to use any other model, you can just swap out the model here. Once you have the results, throw that into our process frame. We get our alert and our annotated frame. We can save it, we can visualize it. Right now, we're just going to throw it into our latest frame global variable, so we can show it in our front end with an API. So now let's go down to the endpoints that we have in our backend system. So we have our get endpoint, where we have our API and cameras. This is just going to query all our cameras in the database, loop through them here in a list, and append all the information that we have in our database to our camera list, which is again just a function. We're just returning this when we call this endpoint. So this is an endpoint to just get all the cameras. We have a post endpoint here as well, which is going to create a new camera. We have the API URL. We just need to send in our JSON with our camera. So this endpoint, it takes in a dictionary with our camera, and this is the 4 values that I showed you inside the settings tab for creating a new camera. So yeah, we just get a dictionary with our camera information. We post this. We create this post endpoint, and we basically just add it to our database. Then we're fetching it to retrieve all the cameras that we have available. We also have an endpoint to just fetch all the latest alerts. Again, it's just going to return the alerts. It's not fully functional now. Model request, we have a start webcam stream. So depending on what type you have specified, update detection, segmentation, post estimation, you can also modify these functions. But we just get a model request here with the model type. So we have a base model, the model type, update taking segmentation, post estimation. It's going to run with that. Get all the live cameras. So we have a stream type equals set to live if the camera is running. We go down here, just set up our camera threads. So for all the live cameras that we have, we want to create a thread for each of them, exactly as I showed you before. So we have our video capture, we have some frame logs, what cameras are running. So when we load in our cameras to start with, we set them to running as default. You can make changes to whatever fits your application, and then we just have a thread here that we are starting to capture frames. As you remember, this capture frames for camera, this is actually like what captured the frames, but also did all the processing, so the process videos that saved the alerts into the database. So we set up a video capture, we start our thread, and then we have everything running. So this is just start webcam stream. Here we have stop webcam stream. It's just gonna stop the individual threads running. So we have individual camera controls as well. We can process a frame with a camera ID. So what this is going to do is just basically just return a response with our process frame endpoint. So we need our camera ID. And then when we call this, we're going to process a single frame. It's going to return the output results from our latest frames. Shutdown event, save event of database. We already went through that one. It's just going to get the camera name from the camera ID. We create an event. We add that event to our database. Here we have the endpoint to create a camera. So these are the endpoints that we're calling from the front end to go in, do the functionality in the backend, and then the backend is doing a bit of analysis, a bit of calculations, throwing it into the database, and then we just have other endpoints sitting on top of our database to retrieve the results and get it into our front end. So we created a camera here, our camera name, camera stream type, the stream and location. This is what we're going to commit to our database. So here we just add it, commit, we refresh our database and return the results here. Here we can delete a camera as well. We can start, stop camera, add camera, delete a camera. So all the functionality is in there. First of all, when it's running, we just initialize our database. Very important, pretty much intuitive. We can also get our detection stats summary, so the total detections, update detections, segmentations. These are just some get endpoints, so we can use this for front page, dashboards, all the different metrics that we are showing in there. We could also get our classes, so this is mainly if you want to do visualizations, our dashboards, the graphs and all that. You can have just endpoints returning the data from our backend systems. So we can return some detection stats about our classes, object classes that we're detecting. We can get our daily endpoints or daily data, so to say that we have a specific day. So get daily stats, model, class name, and it's basically just going to go in, grab today's date, query that in our database, and return the results that we can show in our front end. You can extract weekly results as well. We take a week ago, so the current time delta, subtract that with a time delta of 7 days, we get a week, and we just query that. So we can have daily charts, weekly charts, monthly charts. You can do whatever, modify these for your own needs. We can get all the camera threads available just for some logging, seeing what's up and running, real-time detection stats. So what's going on right now? How are the system performing live? So if we get a new detection, this is basically pretty much just going to update this in real time in our dashboards. And again, we just query our database, check what cameras are available, return the results in the format that the UI expects to create our visualizations and dashboards. We can get some detection stats about the top classes that we have. We have camera performance. This is really good. We have the uptime on the front page, hourly pattern, hourly, daily, weekly, monthly. All these things here are pretty much just copy paste, but for creating the dashboards. So you could have another service instead of inside the main.py file. You could have a separate file, a separate folder where you have your dashboards and analytics service running, and then you can connect it to your fast API app as well. Start camera stream, we just need to have our camera ID. We check the model type in our request. We're gonna get the specific camera from our database. We're gonna set up our thread with our camera, so it just starts the processing in the background. This also means that if you close your front end, if you go to another page inside the front end as well, it will still keep processing the frames under the hood. We're running threads in the background as fast as possible, and it both works on CPU and also GPU. Stop camera stream. We just have an ID that stops it. We go through our camera. We need to retrieve our camera again first. Grab the thread, the specific camera thread that ID has, and then we can go in and stop it. Delete all our video captures, our frame logs, latest frames, all the resources for that camera. It's very important that we go in and release this so we don't have memory leaks. Could be that you can't handle the streams in the threads later on and so on if you have some leaks in your data somewhere. This is very important. Make sure that you're using this as well. Start camera ID, stop camera ID. This is pretty much self-explanatory. This is the full backend system that goes into our full computer vision system here, where we have our home page. So this is just sitting on top of our database, get endpoints to get all the information. We have our dashboard, gets all the information, live analytics. You can set up a camera, start stream, stop stream. We can stop and start the individual cameras. These are all the endpoints that I showed you at the end. A few models for detection for a camera. Have our backend APIs, endpoints doing whatever we want, and then of course in the exact same format that our front end expects. Then you can play around with it. In one of the upcoming videos, we're going to go through how we can modify the front end, what we're doing in the front end, how we're calling the APIs and backend systems from the front end as well. And that's pretty much it. At the end of the day, it's a pretty simple system. Of course, there's a lot of code in the front end part of it, in the back end part. A lot of it is redundant, a lot of it is error locking, just handling all the different threads and all that, but 1,000 lines of code, and this is with all the processing for also analytics, both post information, update detection, and instant segmentation. All these things are handled in 1,000 lines of code. Database connections, everything. So make sure, go in and check it out. It's open source on GitHub. You can make modifications, do whatever you want, use it for projects, learning purposes, and so on. But if you're a computer vision AI engineer, it's very important to not only know how to set up an OpenCV Python script, how to run an analytics YOLO model, and so on. It's much more about how can we build systems around it. The model itself is probably only 20% of the work. The other 80% is building out the database, the backend system, the front end, get it out there, provide business value. Because most users out there, they have no clue about what's going on under the hood. They only see one thing, that's the front end, how the system works, and what business value it actually provides. Go ahead and check it out. Hope you learned a ton. Pretty long one here, but I want to go through all details, log all the progress that we're doing. Now we already have a new cool looking front end compared to last week where we had the other video coming out. Follow along, follow on YouTube, Twitter, LinkedIn, everywhere pretty much. Go through the video again if you need more details, and then I hope to see you guys in one of the upcoming videos. Until then, happy learning.